Okay, we're now ready for problem 23 of this midterm review. Problem 23 says, find the exact value of each of the remaining trig functions of theta. And here's what they tell us. They tell us sine of theta equals negative 5/6, and the tangent of theta is less than 0. So we got this angle theta, and basically they give us the sine, and they want us to find the cosine, tangent, cosecant, secant, cotangent. Now the first thing, this is sort of a two-part problem. The first part is let's figure out which quadrant this angle is in. Because when I begin to determine these trig functions, the last thing I'm going to do is make sure that the sign is correct, whether the trig function should be positive or negative, and that's going to be determined by which quadrant theta is in. So since I know the sine of theta is negative, sine tracks y, so far I know it has to be quadrants 3 or 4. And now it also says the tangent of theta is negative. So which quadrants is the tangent negative? Remember, tangent, sine over cosine. So for that tangent to be negative, it must be the quadrants where the sine and the cosine are different, where one of them is positive and one of them is negative. Where does that occur? That occurs in quadrant 2 and quadrant 4. So what do we have in common? Quadrant 4. So we know the angle theta is in quadrant 4. So as I begin to determine these trig functions, I'm going to use that fact to determine whether the trig function should be positive or negative. So, knowing that, let's actually go try and figure out some of these trig functions. What I'm going to do, what I like to do is, I'm going to take the trig function they've given me, and there's other ways to do it, but for me, I like to just go ahead and create a right triangle. And use this information. I know sine, SOHCAHTOA, is opposite over hypotenuse. So I'm going to create a right triangle based upon this trig function. Opposite, and I don't care about the sign. Right when I'm creating my triangle, I'm not worried about whether it's positive or negative, because obviously distances have to be positive. So the opposite is 5, hypotenuse is 6. I'm going to use the Pythagorean formula to figure out the length of this side. So of course you're going to take the hypotenuse and you're going to square it, and you're going to subtract the other side squared. 36 minus 25, I believe this side is going to be square root of 11. Now that I know the three sides of this right triangle, I can now go start to figure out all the rest of my trig functions. I already know sine, cosine, so ca, adjacent over hypotenuse. Adjacent is square root of 11. Hypotenuse is 6. Now don't forget, so this allows me to find the value, but the last step is determining whether this should be positive or negative. I know my angle's in quadrant 4. What is the cosine in quadrant 4? Cosine is actually positive. Alright, so cosine of theta is square root of 11 over 6. I already know this. Let me just rewrite the sine of theta. Let's do tangent of theta. SOHCAHTOA. Tangent is opposite over adjacent. Now, what is the tangent, positive or negative in quadrant 4? Well, since the tangent is sine over cosine, I know sine is negative, cosine is positive. tangent's negative. We also were told that up here. So either way, we know the tangent's negative. Now the rest of trig functions, we don't have to really do any figuring out. We can just take our current trig functions and take the reciprocals, right? Cosine is paired up with secant, so I know secant, take the reciprocal of this. As a matter of fact, just so you know, in case you want to get rid of the square root out of the denominator, this would end up being negative 5 square root 11 over 11. For the secant, 6 over square root 11. Since cosine's positive, secant's also positive. If you want to rationalize it. Sine gets linked up with cosecant. Negative 6/5. And then the cotangent is a reciprocal of the tangent. Let me start with this one. Negative square root of 11 over 5. All right. So now moving on to 24. Says find the values of sine, cosine, tangent, cosecant. So basically find all the trig functions. If, and they gave me this, looks like a point P, 1/2 negative square root of 3 over 2. If this P is a point on the unit circle that corresponds to the real number T. So basically, so this is a point on the unit circle. My guess is if this is the x, which is 1/2, which is about right here, and negative square root 3 over 2 is like negative 0.7, my guess is, it's negative. It must be, you don't have to draw the picture here, but just to visualize it, looks like this point's down here. And now, just to make it clear, that point, and then they ask for all the trig functions of this point, and they call it, for some reason, they call it like, they like to call that angle T for this problem. So they want to know all the trig functions for this angle. But the key is, since it's a unit circle, what do we know? We know basically at this point, that's the cosine, and that's the sine, right? For a unit circle, normally we use a unit circle and we have just our special angles. And we know on the unit circle, when we look at our special angles, we know the x and the y of that point is going to be the cosine and sine. Here, although I think this is actually one of our special angles, but it doesn't really matter because all I know is this is a point on the unit circle. Since it is a unit circle, I know the x is the same thing as the cosine and the y is the same thing as the sine. So therefore, when they say find all the trig functions, there's not a whole lot to it. The sine is negative square root of 3 over 2. The cosine is 1/2. The tangent, if I take sine over cosine, negative square root of 3 over 2 over 1/2. If you convert this complex fraction, it ends up being negative square root of 3. And then the final 3, sine is reciprocal of the cosecant. So negative 2 over square root of 3. Cosine is the reciprocal of the secant. It's going to be 2. cotangent t, reciprocal of tangent. All right, not very hard. The whole key is the point is on the unit circle. Once that's true, we know that's the cosine and that's the sine. Actually, a pretty easy problem. All right, ready for 25. Now here, I'm going to read the instructions, although the instructions I'm not necessarily going to follow. 25 says, use the fact that the trigonometric functions are periodic to find the exact value of the given expression. Do not use a calculator. Sometimes I think the question confuses people more than just, so basically they're saying, what is the sine of 390 degrees? All the wording in the question probably makes it more confusing than it really has to be. So just, if you're ever in doubt, or one of the safest things to do with problems like this is let's just try and sketch out this angle. 390 degrees. Well, I know once around the circle is 360, so I have 30 more degrees to go. So this is 30 degrees. This whole thing, of course, is 390 degrees. So basically, we say 390 degrees and 30 degrees are coterminal angles, which means sine of 390 degrees is the same thing as the sine of 30 degrees. Sine of 30 degrees, we go back to unit circle, 1/2. All right, not bad. 26. Same thing, use the trigonometric functions, da 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 da. I'm not even going to read it. Basically, they're saying don't use a calculator. They want an exact value of cosine of 33 pi over 4. If you look at this number, hopefully you realize right away that it looks like that's going to be at least one time around the unit circle and maybe more. So let's think about this. In radians, oh, I shouldn't have drawn the circle. Let's just do this. In radians, one trip around the unit circle is 2 pi. However, let's think, what would 2 pi be if I had a denominator of 4? Actually, 8 pi over 4. So the first trip around the unit circle, I can think to myself, I go 8 pi over 4. But then the second trip, I go 8 pi over 4 more, which means I've gone 16 pi over 4. If I go third time around, I'm up to 24 pi over 4. And now if I go, and I'm trying to get to 33, one more trip around, and I get to 32 pi over 4. So I'm not going to draw it here because it probably gets too messy, but I have to make 4 trips around the unit circle. When I make 4 trips around the unit circle, my angle is 32 pi over 4. And now, what I have left, I have pi over 4 left, which is this. So once again, these are like coterminal angles. Cosine of 33 pi over 4 actually equals cosine of pi over 4. And what's a cosine of pi over 4? Square root of 2 over 2. All right, so we are rolling right along. 27. Once again, I don't really like the instructions because I'm not going to really follow what they tell me to do, but I am going to determine the answer. And once again, in math class, for me, I don't necessarily care as much about how you solve the problem, because usually in math there are multiple ways to do it. However, I do care if you can get the correct answer, because this one says use the even-odd properties of the trigonometric functions to find the exact value of the given expression. Do not use a calculator. All right, so we're not going to use a calculator. I agree with that part. And we're going to try and find what the sine of negative 60 degrees is. Now they talk about the even and odd principles, which you could use, and if you want to look in the book and read about those and sort of memorize those, that's fine. For me, I'm just going to say, what's the sine of negative 60 degrees? Negative degree means you go counterclockwise. So negative 60 is going to be about right here. Now if I think to my unit circle, in positive degrees, that's 270. If I go 30 more, that's 300. Negative 60 degrees is like a coterminal angle. I know from my unit circle what the sine of 300 degrees is. This is this point here. This is the sine is negative square root 3/2. If you look on unit circle, this is one of my special angles. All right, now 28. We start something different. It says determine the amplitude and period of the following function without graphing. So now, once again, I don't have time to go into great detail and explain how this works. You can go back to some of the module videos to get a teaching on, we call these trigonometric graphs. So this question has multiple parts. So here's the equation. First thing they ask for is the amplitude. The amplitude is the number in front of the trig function, but be careful, amplitude is always a positive number. So even though there's a negative 2/9 here for the actual answer, we just put 2/9. Now, if I write the standard function, it's like this, so amplitude is like big A. The next thing they ask for, they actually say, what is this omega? And that's why I wrote this. Of course, the omega is the number that's multiplied by your variable x. So that's pretty simple. Omega 7/5. And the last thing they ask for, they ask for the period, which is always labeled capital T. The period, remember, there's a little equation, and it is, I'm trying to remember myself. The period is 2 pi over omega. I just determined the omega, so it's 2 pi, omega 7/5. Now this is a complex fraction. You can't leave the answer like this. Let me remind you again how we simplify this. First of all, I've got a fraction on the bottom and a number on the top. Just to make it very clear, I could change the top and do a fraction like that. And then now a complex fraction is you take the top fraction and you multiply it by the reciprocal of the bottom fraction. So that you can see 10 pi over 7, and that's your actual period. So here are the three things they asked for. The first two, it's just a matter of knowing what's what inside the equation. And the last one, we have to do a little bit of math. Not too bad. Now 29, I think I'm going to have to show you this one. '29 is, they give you another trig function, and then they give you 4 possible graphs. Now before we look at the graphs, let's go ahead and just figure out some information about this, almost like we did the problem before. The amplitude is going to be 9, so when we look at our 4 choices, right away I'm going to check to see which ones have the highest 0.9 and the lowest -9. The next thing I realize is, since it's going to be a cosine, I know when I start looking at the graph of the cosine, since there's no phase shift, cosine at 0 always starts high. So when I look at my graphs, and we know that's actually going to be 9, and this is -9. And then the next thing I'll do, because I know this omega is pi over 8, then I know the period is 2 pi over pi over 8. If you simplify this, the pi's cancel. 16. That means when you start here at the period and you get to the end where you start repeating, you've got a distance of 16. So based upon that, now let's look at my 4 choices. First thing I'm going to look at, I'm going to see which of the choices have an amplitude of 9. So if you can see these, this first one, amplitude's 9, and here's -9, so A is okay. Look at B. B is 8 and -8. So it's not going to be B. I can almost now cross off the B. C, amplitude's 9 to -9, that's good, so it could be C. And then D, I'm back here, 8 and 8, so I know that's not correct. So right away, I've narrowed it down to A or C. And now the next thing is, remember the key, as I said, when you have a cosine graph with no phase shift, the high point is always right there at your y-axis. Let's compare these two. Look at the high point here. It's offset. Look at the high point here. And that's why C is correct. All right. So now, problem 30, I believe, is going to, it says find the amplitude, the period, and the phase shift of the function. Now we have a phase shift. So here's the function they give us, y equals -2 sine 4x plus pi over 2. So they said find the amplitude. Amplitudes, let me write down the general equation. A sine omega x plus, I think they have this, I think this is called psi. spelled PSI, but it's a Greek letter pronounced psi. So what do we have going on here? I'm trying to remember, even me, whether this here is plus or negative. And I think it's plus. Different books do it different ways. That's why I can't remember for sure. But I think this book, the book we're using, is omega x plus psi. Well, as we work it out, we'll see if I get the correct answers. But I'm pretty sure this is correct. Let's go ahead. First of all, they ask, what's the amplitude? Amplitude's easy, right? It's the number in front of the trig function, so it's going to be not -2, but 2. Amplitude's always a positive number. The period, sometimes we call t, the period is 2 pi over omega. In this case, omega is 4. That one's pretty easy. Period's pi over 2. Now the phase shift is actually I think this is backwards. I think it's psi over omega. So psi is actually, looking at this answer, whoops, that's my problem. I think they want this to be minus. You can quickly look in your book and confirm this, but when I have the answer here, and I think to get the answer I want, that has to be minus, because psi has to be, it's not pi over 2, it's negative pi over 2. Since it's minus this, why do I say that? Because you know what? Sometimes this confuses students. I want it to be 4x. I want a minus here. If I put a minus here, what do I have to put here for this to be true? I have to put a negative pi over 2. So therefore, that's my psi. 4x wx minus psi. So omega x minus psi. If you simplify this, and these are correct answers. So this is definitely, I couldn't remember how this book did it. Looks like omega x minus psi. All right, so this is a good place to break, and we'll do a few more of these, and we're getting close to the end. I think on this review there were 43, so we're getting close, but let's stop for now and we'll start the next one.